Okay everyone, today we're going to be talking about Chapter 18 and we're going to look over a couple of problems about the inference about means. And so for number 1, let's say we're going to look at body temperature and the degrees is in Fahrenheit, and let's say we took a random sample of 130 adults. Suppose for this data the sample mean is 98.25 degrees and the standard deviation is 0.733. And so before we start trying to do this problem, remember for inference for means, we want to find our degrees of freedom. And so let's just find our degrees of freedom. And so when we find our degrees of freedom, that's our sample size n minus 1. And so here we're going to have degrees of freedom of 130 minus 1, and so 129. And so what you should do is pause the video, write down our sample size, our degrees of freedom, the sample mean, and the standard deviation. And so pause the video and write those down. And so what we want to look at next is we want to find a 95% confidence interval for the mean body temperature. And so remember, when we're looking at a confidence interval for a sample mean, you have x bar plus and minus our critical value t star times the standard error for x bar. And so what you want to do on your calculator is you need to find your critical value, t star. And so why don't you go ahead and find your critical value that way. And so hopefully you found your critical value. And you should have found t star as 1.96. And so when we set up our confidence interval, we're going to have our sample mean x bar, the 98.25, plus and minus the critical value 1.96 times the standard deviation 0.733 divided by the square root of our sample size. Here our sample size is 130. And so why don't you pause the video and try to find your confidence interval. And so hopefully you found your confidence interval. When you work this out, what you should get for your confidence interval is 98.12 to 98.38. And so those are your two values that you should have got when you times your critical value and your standard error, and then you plus and minus with the sample mean. You should have got these two values here. And so, what is that telling us in context of the problem? Well, in context of the problem, what we can say is that we are 95% confident that the true mean, here we're looking at body temperature, so that the true mean for body temperature is somewhere between 98.12 degrees Fahrenheit and 98.38 degrees Fahrenheit. That's what this confidence interval is saying. It might be different if we took a different sample size and had a different sample statistic, but for this problem, we are 95% confident that the true mean for the body temperature is somewhere between these two degrees that we found. And then that's all we can say about this confidence interval. What I would like you to do is make sure you have this confidence interval written down. We're going to come back and look at this confidence interval. And so pause the video and make sure you have these values down. And so what we want to do, we're going to continue with this body temperature, the same information, but let's say we want to conduct a hypothesis test to determine if the data gives good evidence that the body temperature differs from 98.6 degrees. And so what we want to do is set up a hypothesis test, and let's just prove and see if there's any different. And so remember, when we set up for hypotheses, our first step that we want to make is we want to set up the hypotheses. And so you're going to have H0, our null hypotheses. Here we are claiming that the population's mean temperature is 98.6. Our alternative that we want to prove is that if it differs from 98.6. And so we're going to have mu equals, not equal to, 98.6 degrees. And so there's our first step. We have set up the hypotheses. What we would like to do next is that we're going to want to find our test statistic. And so we're going to have T equals X bar minus the population mean mu divided by our standard error. And so why don't you set this up and try to find your test statistic yourself, and then come back and see if you got it right. And so when you have this set up, you should have had our sample mean 98.25 minus 98.6 divided by the standard deviation, which is divided by the square root of our sample size. And so when you found this test statistic, you should have got a minus 5.47. And so right here, here's our test statistic. And so we want to use this to help us find our p-value. And so why don't you pause the video and try to find your p-value yourself. And so the third step is our p-value. Remember, we had degrees of freedom of 129. And so when we looked at our p-value, hopefully you found the p-value out to be as 0.0005. Remember, when we set up our hypotheses, we had a not equal to in the alternative. And so that's telling us we're either looking at the greater than or at less than when we talk about this t-distribution. And so here we're looking on both sides of the curve. And so what you need to do is times your p-value by 2. And so you should have your p-value as 0.001. And so here's our p-value. What we want to do is compare that to our alpha of 0.05. And so is our p-value less than or greater than 0.05? And so it's less than 0.05. And so remember, if it's less than 0.05, we reject the null hypotheses. And so if we reject the null hypotheses, what that is telling us is we have some evidence that the mean body temperature for the healthy adults differs from 98.6 degrees. We have some evidence to say it's different. And so there's how you want to set up your hypothesis testing. You want to make sure you can follow the steps and that you can set this up and work it through. The last thing we want to look at is we want to look at the conclusion that we had. And so here we said our p-value was less than 0.05, so we rejected the null hypotheses. And we want to look at it in comparison to our confidence interval that we found earlier. And so earlier, our confidence interval was 98.12 to 98.38. And so does this make sense that we rejected the null hypotheses? And so remember, when we look at our confidence interval, we were 95% confident that the true mean was somewhere between here. And so here we were saying the true mean was 98.6 degrees. Does that fit within our confidence interval? And so no, it does not fit within our confidence interval. And so that would make sense that we rejected the null hypotheses because we rejected the claim that the mean is different than 98.6. And so anytime we reject the null hypotheses, our true mean, our true proportion should not fall between our confidence interval because we shouldn't have captured it because we're saying it's something different or it's less than or greater than. And so you want to make sure that you look at your conclusion and at your confidence interval. If we rejected the null hypotheses, your mean, your proportion better not fall within your confidence interval. And so you want to make sure when you do these problems and you find your confidence interval and you look at your conclusion, make sure they go with one another. And so what you should do now is just go over this problem again. You work it through and make sure you can set up your confidence interval and your hypothesis testing.